Hi, my name is Aruj Bansal, and today we will be solving the problem chef in two strings. It has a difficulty level of cakewalk, and there are no prerequisites required to solve this problem. Let's now take a look at the problem statement. So chef has a word, and he compares that word with a random word generated by computer. These two words will be given as input to us. Then he tries to generate the word he thought of by deleting several or more characters from the word generated by the computer. These next two paragraphs, they basically describe this process. So, for example, if chef thinks of this word, world, and the computer generates this word, then chef can obtain world from this long string hello world by deleting all characters but keeping this W, this O, this R, this L, and this D. But for example, if chef thought of world and the computer generated world was this string, then we can see that there is no way to delete characters so that we find world as a string in this. And finally, what do we have to do? The last paragraph, it tells us that we are given two strings and we need to check whether it's possible to reduce the computer generated word to chef's word by deleting 0 or more characters. So if you've not tried this problem yet, I would encourage you to go ahead and try it once on your own and come back to this video to watch the solution. Let's now see how we can solve this problem. Let's first take a look at our sample inputs. So we have two sample cases. This is one, and this is the second one. And the first sample case is the same test that was given in the statement. So I'm just going to go over that once again. We have world as chef string, and the second string is the computer string. We want to delete some characters from the second string so that we can obtain the first string. And note that the order of characters here matters. So we can't rearrange any characters in the second string. They have to appear in the same order that they initially were. So to obtain world, we could simply strike off this half of the string. We could keep any W over here. So I'll strike these two. I'll keep the W, this W. Then I'll keep this O. I'll keep this R. We can keep any L from here. I'll keep this one. And we keep this D. And we've successfully formed chef's word. Now let's take a look at the second input, and we have time and the second string. Now the first occurrence of T in this string is over here, and after this we can say we have I, we have M, but unfortunately it ends and we don't have an E. So here the answer is no, because we cannot delete several characters from the second string to obtain time, and here the answer is yes, because we can delete several characters as I have shown to obtain the first string from the second string. So how do we solve a problem like this? So let's start off with a brute force approach where for every starting character in the second string, so E, M, A, C, H, every character, we try to form the word given by chef starting at that character. And suppose we do have a character to start at. For example, if I start at this E and then I have to compare it with the first character of chef's word. Now we can see that they don't match, so we have to keep on going. But when we do find a match, we go over to this T, and now we have to compare the second character. So we compare I, and then we compare M. What would happen if this I wasn't the next character in the string? So for example, what if the second string given to us was something like T, E, I, O, U, M? What will we do in this case? So we compare T with T, we found a match. Now we have to compare this I. So we keep on going until we find this I. We go to E, we see that it's not equal to I, that's okay. Now we move on, we find this I. And now we have to find an M after this. We go forward and then we find this M. Now unfortunately again, we've run out of characters and the answer is no. But this is one approach that we could potentially look at. And so what's the time complexity for this? So chef string is string T and this is string S, and the time complexity for doing this would be O of s squared, because from every starting character, we could potentially visit the whole string. And of course, this won't pass because we have 1,000 test cases. And if we do an O of t into s squared solution, this is equal to 10 to the power 9 operations, which is too slow. So how do we speed this up? So we need to observe here that, let's say we have a string. This is a computer generated string. I'm going to write down a random string. And the string given by Chef here would be SOP. That's Chef string, and this is a computed string. So how do we solve this problem? What's a faster solution? We need to observe here that we only actually need to match the first character. So we only need to match this S with its first occurrence in the computed string. This is because, let's say we can form Chef string using the second S given in the computed string. So we actually can, because we have SOP. Then we can just simply replace this S with this S, and we can still form the string. So through this greedy argument, we can see that it's actually just optimal to consider the first occurrence of S in the second string. And after that, we need to find the first occurrence of O. And then we need to find the first occurrence of P. And here the answer would be yes, because we were able to do this. So what's a more logical way to think of this? Let's say we maintain a pointer PTR. Now this is not a programming pointer. This is just simply something that tells us which character we have to match next. And we say that it's initially equal to 0. And we loop through this computed string. So at A we don't have a match. At S we have a match, and we increment this pointer and we set it to 1. Now we have to find a match for this O. We keep on going until we find this O, and we reach here, and then we increment this pointer again. So we're saying that now we need to find a match for P, and we find a match for P here, and this pointer is incremented again. So now you can see that if we found the first string, which is Chef string, in the computer string, and if this algorithm worked, then the pointer would be equal to the size of Chef's string. That's because Chef string is 0-based index in our implementation. So we just need to check, we need to run this algorithm, we need to maintain a pointer, and we just need to check if the final value of our pointer is equal to the size of Chef's string. If it is, then the answer is yes. Otherwise, the answer is no. And please do keep in mind that you can't rearrange the characters of the computer string. This is a problem that programmers sometimes make, so you should just keep this in mind. So what's the final time complexity for doing this? We have t tests, so we can add t to our big O notation. And now we can see that our algorithm actually works in the size of our string inputs. So that'll simply just be the size of S plus the size of t. And this should comfortably pass our time limit, because in the worst case, this will be around 10 to the power 6 operations, as t has an upper bound of 10 to the power 3, and S plus the sizes of the strings, they both have an upper bound of 10 to the power 3. So we roughly have 10 to the power 6 operations in the worst case. Let's now take a look at some Python code for this. So this variable stores the number of test cases, and then we loop over the number of test cases. T is Chef string, S is the computer string, and we make another variable n just for simplicity, which stores the size of Chef's string. J is our pointer variable. Now for every letter in the computer string, we have 2 checks, and if those checks have been satisfied, then we increment the pointer by 1. What are these checks? So one check is we have to check if the current letter in the computer string, if it matches with the letter we have to match in Chef string. And the second check, we basically check if the pointer is smaller than the size of Chef string. And we'll see why I do this check in a bit. The other check is the check that I have already explained. And if these two hold, then we increment j by 1. J is our pointer, so we say now that we have to match the next character. So if j is equal to n, which is the length of chef string, then we print yes, otherwise we print no. So why did we do this j is smaller than n check? Let's take a look at this code which gives us an error if we don't do this check. I have here the same code with me, and I'm going to be running it on this test, 1, world and world, world, world. And let's see what happens. We got a runtime error. Why did this happen? Basically, if we look at these two strings, our algorithm would have matched the first string with the second string in the first 5 characters. After that, a pointer would have been equal to 5. And the length of the chef string is equal to 5. So it actually doesn't contain the index number 5. Now we would then try comparing chef string, the index number 5, with some other position which is index number 5 in the second string. And this would actually give us an out of bounds error because that index doesn't exist in chef string. So this code gives us an error, and that is an important check. And now let's take a look at the same code in C++. So again, we have two strings, t and s. We maintain two variables, this time n and m, which store their sizes. We have a pointer variable j, which is initially set to 0. We have the same j is smaller than n check. And if we have a character match, then we increase our pointer by 1. If j is equal to n, which is the size of chef string, then we print yes, otherwise we print no. And this code gets unaccepted. So that will be it for this video. Thanks for watching. I hope you like this problem and my solution for it. If you have any doubts, you may leave them in the comments down below and I will answer them.